Welcome back to Workplace and Apprenticeship 30. We're moving on to section 2.2, which is titled Tolerances. Now before you start, please read the Explore the Math on page 92 and fill out the following definitions from those pages. Alright, so just check to make sure you have the same definitions as are listed here. Then we'll move on to example 1 on page 93. Lana works as a mechanical designer in Edmonton, Alberta. She specifies a dimension on a machine drawing that has a tolerance of 0.020 inches and a nominal value of 0.500 inches. If the nominal value is the midpoint of the tolerance range, how can the designer write the dimension so the machinist knows the acceptable range of the measurements? So for A, we want to, there's a few different ways that we can write it, but let's first figure out half of the tolerance. So this is for part A. We're trying to figure out half of the tolerance. So half of the tolerance here is 0.020, and note this last zero is important because it shows our precision. So what would half of our tolerance be? Okay, 0.010. Make sure you include that last zero in the end because again that shows how precise you're being. Now let's also figure out our max value. So we have our nominal value. So our max value would be our nominal value plus our half of tolerance. So 0.500 inches plus 0.010 inches. It's a total of 0.5010 inches. That would be your max value. So then do the same thing with the min value, except the min is going to be subtracting your half of tolerance. So 0.500 inches minus 0.010 inches, which will give you a total of 0.490 inches. 0.490 inches. So now that we have all of that information, we could write the acceptable range. There's a few different ways of doing this as it showed in your Explore the Math. One way of writing this would be the dimension could be written as 0.510 inches over 0.490 inches. Okay, so that would be how you'd write your dimensions. You could also write it as 0.500 inches plus or minus 0.010 inches. Both of those would be acceptable. You could also look then at your max or your min value. Again, this is on page 93 of your Explore the Math, where you'd write your minimum value would be 0.490 plus your tolerance, which is 0.020, minus nothing, because you're already at your minimum value. So that's your min. You could write the max the same way. You'd have 0.500 plus nothing, because that is your max value, and minus your tolerance. Okay, then we're going to look at part B, which has another dimension here. It gives us a max value of 0.250 inches and a min value of 0.230 inches. I want to express it as the nominal value plus minus half the tolerance. So the tolerance is going to be the difference between those two numbers. So tolerance equals 0.250 inches minus 0.230 inches, which is 0.020. And again, that is the same tolerance as before. And we also want to figure out our nominal value. So the nominal value is usually halfway between the two values given here, so we can actually take the average of them to figure that out. So the nominal value is the average, so we add them up and divide by 2. Which gives us 0.240 inches. So now if I want to rewrite this, I'm going to go nominal value is 0.240 inches plus or minus half of our tolerance. So half of our tolerance is 0.020 0.10 inches. So that would be your final answer. Okay, if you read example 2 on page 95, the first question is, what is the size and tolerance of the hole that Andre should cut? And we know that this hole has to be a little bit bigger than the outlet box because the outlet box has to fit in it, but it has to be smaller than the cover plate, because if it's bigger than the cover plate, that would look ugly because the hole would be sticking out from behind the electrical box. So you're probably going to need some loose leaf because this question is bigger than I thought it would be. So I'm going to answer part A on the next page. So we need to do width and length separately. So let's start with the width. To find the width, let's first figure out the tolerance. So the tolerance is going to be the difference between our our min value and our max value, which is 2 3/4 inches. So tolerance is the difference between those. So we'll go 2 3/4 minus 2, which gives us a value of 3/4. So that's so 3/4 is our tolerance. Now our range is half of our tolerance because we only want to go halfway on either side of that. So our range is 1/2 of our tolerance, which is 1/2 times 3/4. Here's some fraction work, multiply straight across, so we're going to get 3/8 inches is our range. Now the nominal value is going to be 2, because 2 is your minimum value, plus 3/8. Now the reason it's plus 3/8 is because that's the halfway point between the upper and the lower boundaries. So we have the plus 3/8, and then plus or minus half of our tolerance, which is 3/8. So our nominal value, remember, is halfway between your max and your min. So halfway between your max and your min is your min value plus your range, and then you have to still add half your tolerance. So your final answer will be 2 3/8 plus or minus 3/8. And again, that's all in inches. Go ahead then and try to do the length on your own. All right, so check the answer on the board. Note that your nominal value would be this 3 plus 3/4 inches, but your final answer would have your plus and minus in it. So if you look back to the question before, the nominal value would just be the 2 plus 3/8, and your final answer would have the plus or minus part in it. Then if we look back to B, would it be easier to make the hole smaller or larger? It'd be much easier to make the hole bigger. So if you start with a smaller hole, it's easier to shave off the edges around it to make it a little bit bigger for your box to fit in. Sorry, so it would be better to, it'd be easier to make it larger. It'd be better to start with a smaller hole. Okay, so start with it smaller because it's easier to make bigger. Thanks for correcting me on that, you guys. So then for part C, how could we express the answer to be reflected in a way that the tolerance is expressed? So since it's easier to start with the smaller hole and make it larger, we could rewrite this as the width being 2 inches, because that's your minimum value, plus your tolerance, and minus nothing. And you could write the length as 3 inches plus your 1.5 inches, because again, that's your tolerance, minus 0 inches. So we're just taking our minimum values. All right, so next up we have the discuss the ideas problem. Why do you think tolerances were specified for each of these things? So we have a steel door that gives tolerances for the width, height, thickness, location of the lock, and the location of the 3 hinges. So what would go wrong if you did not have tolerances for this? So for the door, it might not fit flush or close properly. For the lock, it needs to fit into the bolt, so they both need to be in the right place. For the hinge, it needs to be equally spaced and aligned with the frame, or else your door will not open properly. For number 2, what do you think a reasonable tolerance would be if the width and height, if the width is 2 inches thick and it is 7.5 feet high? So a good tolerance would have to be quite small, because if any of these were out, your door would not close. So probably 1/16 of an inch would probably be a very good tolerance. Or it could be even less than that, but that gets quite hard to measure. So number 3, what would happen if the tolerances were not followed? So the door might not close properly, hang properly, or it might fall loose or even break. Your assignment then for today is page 100, numbers 1 and 2, and those will be for homework.